getting started with science today. Everyone say hi, Zoel.
Hi, Zoel.
All right. We're excited for him to be able to join us virtually. Now, here's what you need to be successful in science today. You need your science notebook. We're going to be adding some additional notes to it that'll be very helpful. It's going to be helpful for your homework that we're going to review at the end of class. Also, you need your homework. You have your water drop lab. We're going to review that and look at the front side and the back side all together. And then finally, you have your scientific method handout. That should look something like this. It has a scientist at the top and bottom. By the end of class, we will be grading this. This is for a grade. Now, we'll give you a chance in class to review it and double check it before we actually trade it and grade it. All right, so let's get things rolling here. Yes, question?
Will the scientific method handout count as homework grade?
It will be a homework or classwork grade.
Okay.
And your lab that you completed at home will also be a homework / classwork grade.
Okay.
Okay? We do not have any test or quiz grades at this moment in the grade book. Even the short quiz that I gave, usually my short quizzes, I just put them under the label of classwork. Okay? And by the end of class, I'll give you have 2 brand new assignments. You have one that's another lab that you're going to do at home. It's where you test surface tension of milk. So that will be one lab that you do at home. The other is this handout here called Test the Hypothesis. Okay? So you have 2 assignments. They're assigned to you tomorrow, and I'll hand those to you before class is over. All right. We need to get things rolling. All right. Yes?
When are we going to do are we going to do a lab here soon?
Yes, we will. I had originally planned to do one with the popcorn. I'm sure it's a variation of, it's not the same thing you did, I'm sure. But basically with COVID, I was like, I really don't feel comfortable doing that, just to keep everyone safe. So that's why we're doing it this way for now. But yes, we will have labs in this classroom and next door at the Collegiate Center. Great question. All right, so let's get busy here. Everyone should pull out their science notebook, please. Now also, we are going to review your water drop lab in light of the scientific method. So, here we go. Everyone sit up straight. Listening ears tuned in. Everyone paying close attention. You had to follow these 5 steps in your water drop lab, didn't you? So let's review and see how you did that. First of all, we always start in any experiment by defining a problem or asking a question. In this case, you had the question presented to you, didn't you? You were to answer the question, how many drops of water will a penny hold? Now, if you've done this before, you got to use maybe a nickel or a dime or a quarter, so you could change it up a bit. Now, we always start with a question. That's our problem. Kind of like in math, we start with a problem, right? The goal of a math problem is to come up with
an answer.
An answer.
Solution
Or solution, right?
his
Same thing in the scientific method, isn't it, Drew?
Mm-hmm.
You basically work through in order to come up with an answer to your original problem. And you can see that's the end goal, is to find and verify an answer. Okay, so back here up the top, we started off with our problem. How many drops of water will that penny hold? Then you had to form and create a hypothesis. Someone remind us, refresh our memory. Tell us the definition of a hypothesis. I think you know it. Put that hand in the air.
Ooh.
All right, right here.
It's an educated guess, kind of like an inference.
An educated guess, right? So basically, we're using information to help us, aren't we? Is it just a stab in the dark and just a guess, a random guess? You're basing it on information, right? In fact, remember, earlier this week I invited our guest in, Jeannie. Jeannie was a wonderful guest, wasn't she? She taught us a very valuable lesson about a hypothesis, didn't she?
Mm-hmm.
She taught us the more information you have, the better that hypothesis will be. So in your experiment, you had to fill in your hypothesis. I think a penny will hold blank drops of water. Now, some of you guys had done this experiment before. you had the upper hand. You had more information, didn't you? Some of you knew the properties of water, and you knew that water was, well, it has surface tension. Can you say surface tension?
Surface tension.
Now, eventually, you filled your penny. Let's say this is your wonderful penny of science. See, there's the edge. We'll turn it into a 3D penny. Let's say this is Lincoln's face. There's his nose. There's his smile.
Isn't it?
And there's his beard, his eye, and his hair.
His hat.
Yeah.
And anyway, that's our pretend Lincoln.
Huh?
Then it says, "In God we trust." Anyway, okay, sorry. That's a horrible drawing, isn't it?
Yeah.
But eventually, you placed your water droplets on, and you noticed this ginormous bubble. Well, what we're going to do is get into why. Why was there a bubble? Okay. So moving along here. We have the problem defined. You create your hypothesis, but notice before you make a hypothesis, you need to gather some information, don't you? The more information you have, the better your hypothesis will be. In fact, on your homework, notice on your homework, I did not tell you to put 5 steps in order. I told you to put 6 steps in order. You got an extra step. It was the step right before the hypothesis. You need to research the problem to come up with a good hypothesis. Whoa, I just gave you a really big hint on your homework. If you need to get that fixed before we grade it, please do. Now, moving along. After we create our cool hypothesis and give it a really educated guess, then is the fun part of experimenting, right? We get to do the experiment. Now notice, that's not what this says. It doesn't say do the experiment on number 3. What does it say?
Test the hypothesis.
Test the hypothesis. Was that the same thing? Absolutely. Anytime you do an experiment, you are testing the hypothesis. And that's exactly what you did on your water drop lab, didn't you? So what you did is you followed the procedures, put your penny on the clean surface, you followed step by step, and you did the experiment actually 5 times with regular water and 5 times with soapy water, didn't you? So you actually did the experiment 10 times total. So you tested your hypothesis. Now, after that, you classify and you analyze the data. You had a data box, didn't you? You filled in your information in this data box. So after each experiment, you recorded how many drops in your first attempt, second attempt, and so on. And you also did that with the soapy water as well, didn't you? So everyone should have their data recorded and classified. Now, to analyze it just means like you're making sense out of it, okay? That's all that means. Did I tell you the example of the scientist who didn't record his data?
No.
Okay. I'm going to give you this example just purely as an example here, okay? Now, then I have a really good buddy. His name's Dr. Saldivar. Dr. Saldivar lives in Oregon right now. He has a double doctorate, a really educated guy. And he spends his life studying cancer cells. And what he does is he sits in a laboratory pretty much all day testing what responds or what different items do to cancer. So hopefully, he and his team can find some breakthroughs and identify ways to kill cancer. Wouldn't that be incredible? I mean, the big nasty C word, cancer, scares people, doesn't it? If we found the cure for cancer, that'd be incredible. Let's pretend that my good buddy, Dr. Saldivar, discovered the cure for cancer. Whoa, that'd be awesome. People around the world would celebrate, wouldn't they? let's say he discovered the cure and he got so excited he ran out to his car, he hops in his car and he starts driving down the streets. He rolls down his window and he says, "We found the cure for cancer." And then all of a sudden, he has a car crash. He didn't record his data. No one else will know. That'd be horrible, wouldn't it?
So he died?
Now, fortunately, my good buddy, Dr. Sanders, or not Sanders, Salvador, that didn't happen, so. And I certainly don't wish that on him.
Wait, is he real?
He is real, yes.
Okay.
He's a real Dr. Salvador. In fact, the cool thing is, we used to teach Sunday school together. We used to teach little bitty kids Sunday school. And now he's a brilliant mind. I mean,
Teaching big brainiacs.
yes, exactly. All right.
Thank you.
Drew, you have a question?
In robotics, we have to write down our whatever we do. It's actually how Providence won their 3 awards.
Nice.
They got one of them on design, which it wasn't from the design of the robot. It's the way they documented the design of the robot.
So you guys won an award just on this step alone.
I didn't. I wasn't in it last year, but
Okay.
I will be in it this year.
That's incredible, though, because that is so vital and so important, isn't it? Excellent point. Thank you for sharing that. Yes?
And so in 4th grade, our teacher said that he knew someone that thought he had found the cure for cancer because he was testing on lab rats.
Oh, really?
The cure for breast cancer, and so they gave them breast cancer basically, and he tested it, and it worked over and over and over again.
Really?
So he thought he had found the cure for cancer, and then when they were on their way with their data and everything to the Nobel
Whoa.
company, basically.
Not the Nobel Prize, right?
No, to the like put it in.
Okay. Wow.
And so basically, he was driving there, and then there were like vans or things that they were testing. One set of lab rats
It didn't work.
it didn't work on, so
Oh.
they couldn't.
So they couldn't share and present there. Wow.
So.
So classify and analyze data. You can see it's a very important step, isn't it? And then finally, the last and final step, the whole reason we do an experiment is to come up with our answer. Now you wrote your answer, or should have written your answers, on the back side, right? Of your left sheet. Okay. So let's do this. Let's add some information to our notes. You see, there's a new word that you need to know about. It's called replication. Can you say replication?
Replication.
Say replication 5 times fast.
Replication, 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 replication.
You
5
just
times fast,
did
5
the
times
word. Replication means to replicate. Does it sound like repeat? That's all it is. It's repeating steps of the scientific method. So in your notes, under the title Scientific Method, let's go back to our composition notebook. Add in a definition for the word replication. You're just going to put this under the same title, under the title Scientific Method. Now let's add in a definition for replication. Alright, so replication is simply repeating an experiment over and over and over and over. And the more times you repeat an experiment, the more solid your evidence is, the more proof you have of your final answer. So, let me ask you a question here. Did we do replication in this water drop lab?
Yes.
Absolutely, didn't we? In fact, you did the experiment 5 times with regular water and 5 times with soapy water. Now, I don't know if you realize it or not, but you were working with something called surface tension. Can you say surface tension?
Surface tension.
Now, in surface tension, it's when a surface of an object likes to stick together. So back to our little penny illustration. Sorry, it's not very beautiful.
Nope.
But the surface of this water experiences surface tension. That means the atoms of the surface like to stick together, kind of like you and your good buddies. So let's draw some little red X's here to represent surface tension. And that surface tension causes the surface of the water, the top bubble, to stick together. Now eventually, you keep adding more and more and more drops, don't you? To the point where the surface tension cannot hold any longer and the water spills off. Wait. The first time you used water, didn't you? The second time you added something to your water. What did you add, Christy? Soap. When you add soap, soap takes away surface tension. It does that for many things. For example, when you wash your clothes in soap. It removes surface tension so the dirt and grime on your clothing doesn't stick.
That makes so much more sense now.
Yeah, and all the dirt comes off your clothes. Same is true when you wash your hands. When you go to the restroom and use some soap, it takes away the surface tension basically of the germs and it causes all the yuckiness to come off. Now, yes,
So,
Drew.
when I was doing the experiment and I had soapy water, before I cut my hair, I was actually dipping my hair in the water, and I noticed that it would separate every individual hair. So I had like a strand of multiple, and then they separate them all out. But as soon as it came out of the soap, it would stick back together.
Really?
Mm-hmm.
Interesting. So when you add soap to the mix, it reduces surface tension. So when we add soap, basically it removes some of these X's. It removes some of the surface tension. So that means when you added soap, you should have had less water on top of that coin. How many of you guys found out that your soapy water, you had less soapy water on top of your coin? Sweet! That's what should have happened. Now, as you know, I have a son in 7th grade as well, Jackson, and we worked together on an experiment at home because I wanted to see how it went, you know. When we did, we noticed our drops were different. Now, we used the same dropper, but when we used soap, the drops were smaller. Once again, there's less surface tension, causing our droplets to be smaller. So the weird thing was, for us, our average was the same. But if you would have compared coins side by side, the water bubble would have been much taller with the regular water than with the soapy water. Interesting, right? So the soap removes the surface tension. Now, you get to do another experiment tomorrow at home. And for this one, you're going to be working with surface tension, but not surface tension in water. This time you're going to be using milk.
Is this the milk food coloring?
Basically, you put milk in a plate, you add food coloring, then you add soap to see what happens to surface tension. It's kind of a fun one to do. And you may have done this before, I don't know.
I have. It's so fun.
Does the way that works
It's pretty cool.
So the way it works is the milk slightly bubbled up, and then so when it does just like have such little surface tension, it just completely gets rid of it,
You'll have to wait and see.
or does it bring it up higher?
Is a petri dish okay to use?
If you have one, that'd be great. You can just use a plate. Yeah. Really simple. Just plate, milk, and it doesn't matter what kind of milk. You can use whole milk, 2% milk, skim milk.
But is that
It doesn't matter.
Whole milk.
It will vary your experiment slightly, but it will still.
It would probably have.
All right, so at this point,
less.
we've covered all the steps of the scientific method. We've defined replication. In fact, you did replication, didn't you? Let's do this. Let's review the back page of our experiment. On the back side, you had to identify some variables.
Math.
Well, let's review this. On the back side, you had to figure out the independent, dependent, and controlled variables. Let's all review this now. By the way, if you got it wrong, fix it.
okay?
So here we go. On the back side of your lab, it says number 3. What is the independent variable? The independent variable is a factor that that we changed to impact our experiment? What factor did we change in our experiment? So in other words, what was our independent variable? Who knows? All right. What was it?
Us adding soap to the water.
Aha. When we added soap, the soap is our independent variable, right? That's what we changed. Awesome. All right. Next. Question number 4. What was the dependent variable? So in other words, what was the factor getting measured in our experiment? What's the one thing that we measured? Jack? What do we measure in this experiment? What was our dependent variable? Number 4.
The drops of water.
Exactly. We measure the drops of water. So that there is our dependent variable, right? The number of droplets. All right, then finally, number 5 on your questionnaire asks you, what were the controlled variables? There were multiples. Now remember, controlled variables are factors that remain or stay the same. They stay constant. They're locked in. They do not change. What remained constant throughout the entire experiment? Abby? What remained constant the whole time?
The penny.
All right, it should have been the same penny the whole time, right? So that's a controlled variable, absolutely. Anything else? Something else? Yes, Christy.
The eyedropper never changed.
Ah, the eyedropper shouldn't have changed. Anything else? Yes?
We're using water.
Okay, water. Water remained the same. Now, the second time we did add the soap, right? So the soap would be your independent, but water, you could say controlled if it's constant. All right, does that make sense? Did everyone identify their 3 types of variables in your experiment? Wonderful. All right, here's what we need to do next. We're going to learn the difference between a theory and a law. But before we do that, I know you've been sitting there for a while. Let's stand up, stretch. Stretch our muscles out. Breathe in deep, get some fresh airflow to the brain. Get some oxygen in there. All right, here it is. A theory is a logical explanation of events that are not observable but inferred. So it's logical, an explanation, but is a theory 100% proof and fact? No. So a theory is mankind's attempt to answer some hard, difficult questions. Yes?
One thing about theory, so the theory of evolution,
Mm-hmm.
one thing that my science teacher last year told us is, or someone in our science class last year told us that in Charles Darwin's book, it says, if my theory is wrong,
Right.
tell me, and don't believe it.
Oh,
Right.
yeah,
And
we
he
learned
did
it.
pose it as a theory.
We learned it in science. It
we'll have to
said
video about it.
if anything, any slight thing of my theory is wrong, then the entire thing's wrong.
Right.
Yeah,
And
remember
there's
that one video,
already
like,
been proof that it's wrong.
If beetles hadn't had evolved, they would all like explode.
All right, so let's
That's
consider that
giraffes.
theory, okay? That's great that you pointed that out.
What one?
Giraffe.
The theory of evolution. Now,
Those giraffes.
is the theory of evolution based on some logical, observable information? It is. Now here's why, okay? We've observed different species make slight adjustments and changes. For example, we've seen birds and their beaks have changed slightly over time. Okay? Or a common example, dogs. You can take 2 very different dogs and get a new, different dog, but it's still a dog, right? That's why we have all the variety of dogs we have. We have little tiny teacup dogs. We have giant, big beast dogs. But the point is, they're all dogs, aren't they? So yes, we've seen change within species, but we have never, ever witnessed one thing changing into a new thing. For example, we've never witnessed a bird evolve into a reptile. We've never witnessed a dog evolve into something else.
A cat.
Meow. So you can see here, yes. Okay.
Hello, Soul.
So you can see the theory is based on some observable things. But can we say 100% that it's true?
No.
Absolutely not, right? Now, let's look at the difference between a theory and a law. All right, you will need to add this to your notes. Sorry. Laws are very different. Laws are 100% factual. We know they're true. Laws are based on fact. Laws have been proven time and time and time again. For example, there is a law of gravity. It is pulling you down at this moment. Sorry, gravity is, it's a drag.
I thought you said gravity.
Gravity, it's always pulling you down, man.
That
Thanks for the comment.
Oh,
that
okay.
joke, that-
I have a
So-
good joke at the end of it.
Scientific laws have been proven, they are factual. We see them over and over and over again. There's certainly tons of evidence to support scientific laws. Now, on the other hand, theories. Theories, yes, are based on some observations and we're inferring some stuff. But theories are kind of like mankind trying to figure some things out. Theories have some testable explanations, but they're not 100% absolute proven, are they? Not at all. And a theory may have some evidence, but you can't say 100% you know it's true. For example, I think I kind of shared this last week, but remember my son Jackson and the neighbor, they took some explosive fireworks and stuck it in a mailbox over the 4th of July.
That is illegal.
Now, we had consent. It wasn't like we blew someone's mailbox up on. No. So we put it in the mailbox, boom, the mailbox blows up, and we have a phone that forms from this? No. Obviously, it created destruction, didn't it? There's this thing in science that's known as a law. It's called the law of entropy. Can you say law of entropy?
Law of entropy.
Well, the law of entropy states that after something is formed, it decays and breaks down over time.
Do we need to write that down?
That makes sense. No, you don't. This phone, for example, when we first bought it, brand new, it's nice, it works well. Now as time goes on, it's going to start failing, isn't it? Eventually I'm going to have to replace this. Eventually. That's the law of entropy. Things break down over time. That mailbox broke down. Now, the theory of evolution goes directly against that scientific law. The law of entropy would say anything and everything over time breaks down. Well, evolution says there was this big bang that went kablooey and then order came out of it. That's not what the law of entropy says, is it? The law of entropy would say, no, if there was a big bang and big boom, then it's going to create chaos and more chaos and more chaos. So you see, the theory of evolution doesn't line up with some laws that we know 100% are true. Okay. Yes?
Do you really need a law to know that, or can you just use some common sense in an explosion when you're creating like animals?
You know, I think it's common sense. I agree with you.
It's like you don't need like a whole law and everything. It's just common sense and like
Right.
an explosion created a dog.
Yeah, I completely agree with you. It just makes logical sense, doesn't it?
We went.
Yes, what's your question back here?
How many time?
Oh, remember my 5-minute timer went off. So we have to finish things up, okay? All right, here's what I want you to do with the remaining time that we have. Take your homework over the scientific method, review it, double check it, make sure it's your best work. Double check to make sure you put the scientific method in the correct order. And double check your definitions at the bottom. Notice, you now have the definition for theory. That's one of your questions. Okay? So please double check your work. Make sure it's your best work. As you're doing that, I will bring by 2 pieces of homework for you to work on tomorrow. You have your other experiment. Yay. And you have your test the hypothesis. This one's a cool one. You get to read about an experiment and figure out what did they do wrong. They did something wrong. Their experiment is not fair.
Do we need
So-
to turn in our science?
Your scientific method will be your ticket out the door, please. Okay? Jack, I'm gonna put yours right here for you, okay? Thank you. Sorry, we started a little bit late. That was totally my fault. I thought I was waiting for the next bell, and there was no next bell, was there?
I think it was
Can I
all of our
stop?
fault.
Yeah, we all forgot.
We were
Yes, you can
like
do that.
counting down.